Kevin, welcome to the second part of our conversation today.
Great to be back.
Yeah. Kevin, when you look back on your career and all the projects that you have been a part of, could you share about your three of the most defining projects during your career?
Absolutely.
Yeah.
Really happy to share that with you. And again, I'm really happy to be here to talk about this topic with the audience. So I'll talk about one that's pretty fresh on my mind because
Yes, yes.
it was just released, which is a collaboration. It's sort of a public-private collaboration
Okay.
um, between the Charles Pankow Foundation, which
Okay.
is the leading nonprofit organization for promoting innovation in building construction, and
Yes.
ASCE, and it involved multiple structural engineering firms who were given grant money to do this. So what we sort of the culmination of this 2-year project was an ASE design guide. So it was sort of a logical third step. So,
Okay.
developing ASE 7, then the manual practice. But there really needed to be something that brings it all to life and sort of gives exemplar designs from beginning to end of how to do structural fire design.
Yes.
So you can actually go on to ASE Publications website
Okay.
and freely download the electronic version. It's a very in-depth report,
Okay.
almost 300 pages. It's entitled Performance-Based Structural Fire Engineering.
Okay.
So as I mentioned, there was 4 structural engineering firms involved, as well as 4 universities, and
Okay.
the faculty members at the universities basically played the hypothetical role of a building authority, and then the
Yes.
structural engineering firms were the natural designers.
Okay.
And I was really privileged to serve as the principal investigator, as well as one of the 4 industry champions of this project. And
Okay.
what I really, really enjoyed about this process, this 2-year process, was the collegial partnership that these competing structural engineering firms had, as well as the academic advisors, to work together and knowledge share in order to better our industry, sort of, have all boats rise with the rising tide. So I thought that
Yes.
that was really fulfilling. And in the process, each one of the 4 structural engineering teams looked at an anonymized structural design that has
Okay.
regional diversification. So, for
Okay.
instance, I worked on one for the East Coast. There was a design on the West Coast, the Midwest, as well as the South.
Okay.
And in addition to looking at different structures, they were all steel structures, protected steel structures. We looked at different design scenarios, so ranging from what we termed as design zero, which is essentially no design, which is just follow the fireproofing requirements of the building code.
Okay.
However, we took it a step further and actually did the analysis to understand how those designs would actually work. Then we had intermediate designs where the structural engineer was partially involved. Then we had design three, which is really where we want the industry to go, which is the full integration of structural engineers into the process.
Okay.
So we
Yes.
found for the designs where structural engineers were not integrally involved, that in certain cases there was fragilities in the structure that would have not been uncovered had we not done the analysis, which is not required by the building code.
Yes.
So if you read the report, it was universally concluded that structural fire engineering per ASC 7 requirements can improve building performance and enhance the efficiency of the structure. So in part one, and when we talked about it, was sort of a hypothesis that
Yes.
this design method can provide both a better building and a potentially cheaper and more efficient building.
Yes.
This project was a way for us to put in the US public domain proof and transparent as evidence that
Yeah.
it can indeed be achieved by structural engineers.
Yes.
So the The design guide is broken into two parts, part one and part two. And we did this strategically because we want part one, we developed it in a way that could be read by users of the technology, such as building authorities, developers, architects, to basically get
Yes.
a flavor of the process, but not
Yes.
necessarily
Yes.
get bogged down in the minutia of the analyses.
Yes. Yes.
Then there was a part two, which is for sort of fellow structural fire engineering junkies like myself that want to actually be producers of the technology. And we
Yes.
hope that there's going to be a lot more structural engineers that will be producers.
Yes.
And
Sure.
this part two provides very transparent and replicable calculations and analyses that can give some added confidence to structural engineers who are looking to become involved in this area.
Yes.
Um,
Yes.
Another project that comes to mind that's more of a real life project and not hypothetical designs is LaGuardia Airport in New York.
Okay.
This is $8 billion reconstruction project, and it was sort of motivated by the airport. It's well publicized that this airport's been plagued by flight delays in past years, and it's primarily attributed to a lot of congestion of the aircraft taxiways. So, not having enough efficient paths for aircrafts to get to their terminals. So, the designers, in order to allow for the airport to continue to function and also to alleviate the congestion, they came up with a concept of having pedestrian bridges that would span between the hub of the airport and the terminals of the airport and
Okay.
actually allow aircraft to go under these pedestrian bridges. And it's actually the first time in the world that this has been attempted. So the building authority had a lot of concerns about this because there could be fuel spills under the bridge due to the aircrafts, which then could create a very big fire hazard to the bridge.
Yes. Yes.
So there was a lot of contemplation about how do we protect this hazard? Do we have to have these really elaborate active foam systems to put out these fires, which are very difficult to implement and expensive? So
Yes.
we thought that this would be a great opportunity to introduce structural fire design. So we had a really good dialogue with the building authority that we are going to do a structural fire design per ASC 7, and we're going to prove and also engineer the fireproofing to a level that allows for the full burnout of all conceivable scenarios and
Okay.
provide the necessary robustness of the structure in order to satisfy both occupant life safety and firefighter life safety concerns.
Yes. Yes.
So we did evacuation modeling of occupants, how long it takes them to get off the bridge and to exits. We did fire modeling where we looked at 8,000 gallons of jet fuel being, spilled accidentally on the tarmac and then ignited. And we were looking at different locations along the bridge of where there was pool fires would be, because it's really a localized fire exposure to the bridge. And if you have it at the midspan of the bridge where an aircraft is passing by, that would have a different response on the structure than if the aircraft were parked near a terminal and then accidentally spilt its jet fuel and got ignited.
Yes.
So we
Yes.
looked at it, it's almost like live load patterns in structural engineering, but it's actually a flame
Yeah.
that you're moving across the bridge. Um, and then based on those fire modeling calculations, we did thermal modeling and structural modeling, and we
Okay.
developed DCRs for every member of the truss. And we also looked at the global behavior of the bridge, and we then engineered the structural fire protection to a level that we didn't need active suppression below the bridge. We
Mm.
relied on the intrinsic safety of the structure. So that
Yes.
was a
Yes.
that was a really good proof of concept of structural fire design per AC7 working for a difficult problem in the United States.
Yes, yes.
A third project that comes to mind is a pretty iconic project. It's actually the tallest building west of the Mississippi. It's the
Okay.
Wilshire Grand Tower in Los Angeles.
Yes. Yeah.
This is a $1.2 billion project, and it has gravity and lateral members that connect to the core of the high-rise building. And at this connection point are very large embedment plates with anchor studs. And at these embedment plates, because of their massivity, they were so large that the anchor plate actually descended below the finished ceiling line
Okay.
architecturally, which those embedment plates under the prescriptive method would require fireproofing. And if you had these embedment plates sticking below the architectural ceiling line and it was very ubiquitous through the whole building on all floors, it would pose a very aesthetic hardship for the designers. So it's something that they wanted
Yes,
to
yes.
avoid. Now, if they were following the prescriptive provisions of the building code, they would have no option of, their only options would be to actually fireproof it and live with the unsightly conditions or lower the architectural ceiling significantly, which again, in terms of the programming, would have a big effect.
Yeah, yeah.
So structural fire design, and this became a very big delay in the construction, and delays in construction of a project of that magnitude can be very significant.
Yes, yes.
So we propose to employ structural fire engineering per AC7 to look at partial protection methods and to ensure that the embedment plates have sufficient capacity under extraordinary event live load combinations. So
Yes.
we looked at both fire and thermal modeling to understand the thermal demand on these embedment plates and the members that frame into them.
Yes.
And one thing that we were concerned about is the unprotected portion, the bottom segments of these plates would act to thermally bridge into the shear studs. So we need to properly analyze and show the flow of heat there under fire conditions. Also, structural calculations were performed. And for full burnout uncontrolled fires, we demonstrated that the structure partially protected under our scheme would provide satisfactory intrinsic safety. So this was a really big um, proof of concept in the sense that
Yes.
this is an iconic project where the stakeholders were willing to employ this, and it actually dramatically affected the construction schedule. So it alleviated a major impetus that was in their
Yes.
way.
Yeah.
And I remember that there was a ENR article that came out at that time that I was quoted in, and others in that are developing the standards. Um, and the stakeholders of this project sort of held up this article with, proudly that
Yes.
this was applied on this building. So they weren't trying to hide the fact that they did an alternative method. It was very much, there was a lot of pride that we,
Yeah.
analyze the intrinsic safety.
Totally, totally. Those are some great projects that you had an opportunity to work on during your career. And hopefully you will be working on many of such amazing projects in the coming future.
Absolutely.
Yeah. So, Kevin, which has been the most technically challenging project that you have worked on in your career, and why was it challenging?
So one that comes to mind is something that, and you may have seen this on YouTube, um, the hyperloop concept. So
Yes.
essentially, it's a concept of transportation where it's proposed to connect cities, for example, San Francisco and Los Angeles, with this infrastructure of concrete tubes that are raised
Yes.
above the ground on collars.
Yes.
And the inside of these concrete pipes essentially would be depressurized to create a near vacuum.
Yeah.
And then within the tubes, they would shoot or propel passenger pods that are referred to as bogies
Yes.
between the cities, approaching the speeds of an aircraft. And they use things such as magnetic levitation, and the near vacuum environment reduces,
Yes.
the air resistance to, a very small amount. So it's really, a wave of the future.
Yes.
And, I was involved in coming up with a concept of how do we make this fire safe. And you open up the building code and there's nothing that talks about hyperloops. But that didn't preclude us from having to address the concerns of the building authorities. So
Yes.
for this type of unique infrastructure, we were forced to do a performance-based design. And these are very unusual conditions that we had to put a lot of thought into. And this really goes back to my passion of open-ended problems and coming up with solutions. And controlling fires is a challenge within this environment, because the annular space between the bogies and the tubes is relatively small.
Yeah.
Um, so there's going to be a lot of shielding of, say, sprinkler water spray, and it can be pretty difficult to get water to the fire because it may be in sort of a shielded location.
Yes. Yes.
So we conceptually developed a water mist solution where these nozzles at high pressure
Okay.
spray water mist, and the mist can get into shielding and sort of interact with the fire in a way to help control it in its incipient phases.
Okay.
Another thing that's difficult is if you have a fire within a tube. It's a confined space, so controlling smoke, it can be very difficult. If there's a fire event, what happens in order to get people out of the bogies into the tubes and then out of the tubes, um,
Yes.
is the near vacuum needs to be repressurized to a point where it's safe, where it's a safe environment to traverse. Um, and during that sort of sequence of events, we also have to be controlling fire. So we came up with a conceptual smoke control design that
Okay.
has large fans, creating pressure differences in a way, and exhausts of smoke, to allow occupants a tenable environment to traverse, to get to essentially what are these escape hatches
Yes.
from the tubes. So it's very unique. It's very different from being in a building where they, during a
Yes.
fire
Yes.
alarm, you go to the stairwell and you go down. So for the hyperloop concept, there's going to be a lot of education, and there needs to be a lot of thought into getting people out of those environments if there's a fire. And
Yes.
even
Yes.
things that we take for granted about, like fire alarm devices. Um, in a near vacuum environment, if you just put a fire alarm device in there, the pressure difference between the outside of the device and the inside could actually cause it to collapse.
Yes. Yes.
So we actually had to come up with ways that we could introduce weep holes into these devices and not
Yeah.
violate their listings.
Yes.
So
Yes.
again, that a lot of hurdles there.
Yes.
And again, the projects with the most hurdles tend to be the more exciting ones because they're really
Yes.
pushing the
Yeah.
envelope, and this is certainly one of
Yeah.
them.
Yeah. The more the challenges, the more the learnings that you get from the project.
Exactly,
Yeah.
exactly.
Kevin, that brings us to the end of our question segment. Let's move on to our next segment to explore Kevin's skills as a cartoonist enthusiast and gain a few takeaways from his learnings. So, for this segment, I have asked Kevin to sketch up something imaginary that he feels should be a reality in the future in our industry without keeping in mind any of the constraints at this point. Let's check out what he has sketched up for us today.
So if you don't mind, I've actually made a couple sketches. They're on
Yeah,
the
yeah, sure,
same
sure.
topic.
Sure, sure.
Um, so this one right here, as you can see, a couple cartoon characters that I grew up drawing. So I sort of coming full circle. Um, And this cartoon character is envisioning a type of connection that may provide fire resiliency. So a lot of times on structural drawings and designs, it will say something of the like that connections designed by steelwork contractor to these loads.
Yeah.
And as we talked about, conventionally, those loads are for ambient temperature loads such as wind and seismic. Um, but I'm hoping in the future, again, we begin to design structures for earth, wind, and fire. So
Yes.
I would envision in the future not just certain lateral loads and their effects on connections and gravity and shear, but also thrusts and pulling loads on connections, and rotations on connections. Would be a stipulation of the design working, because um, primarily the members that connect into columns can be very, very important to a structural fire design. For example, if you're designing the floors to become stable membranes, you need to ensure that those connections are adequate.
Yes.
So what
Yes.
I'm
Yes.
showing in this cartoon is potentially moving a typical shear connection up into the slab. And this is something that's sort of been, batted around in committees I've been on. So, I'm not the
Yes.
sole inventor of this.
Yes.
But it's an interesting concept because it's a way to reliably thermally insulate the connection, because as I mentioned, furnace testing doesn't include connections. So when the
Yeah.
connection undergoes rotation and translation under fire, brittle type fireproofing may not hold up. But if it's embedded within the slab and under ambient loads, the only thing that you're looking to do is to transmit shear. This may be, a unique way to transmit the shear, but also to enhance the robustness under fire, because it could much more reliably insulate the connection.
Yes.
And
Yes.
also, it, due to its eccentricity from the thrust and pulling line, and the shear flexibility that would be perhaps designed there, you could lower the thrust demands on connections, so bolts and things would be under less stress potentially. And also,
Yes.
it may look pretty cool and eye-catching to have beams
Yes.
sort of floating there. So this is
Yes.
just one concept.
Yes.
Here's another one where my cartoon character is very, very excited that he came up with this idea. And instead of embedding the connection within the slab, there could perhaps be a quote unquote safety platform that
Okay.
the beam sits on. And what I'm thinking is that that type of platform would be helpful during the erection of the steel, but also it can act as sort of a secondary belt and suspenders support if the shear connection were to rupture under the forces of fire effects, the expansion and contraction. Now, we saw in World Trade Center 7, if you read the publicly available NIST report, that expansion of other floor beams that are expanding into primary members can
Yes.
actually push beams off of semi-rigid connection seats. So, this platform would have to be wide enough, or perhaps maybe sort of oval in a way, to keep the beam seated and not be able to slide off. But those type of things, it really unlocks a lot of potential if we're synergizing fire protection and
Yes.
structures, because we can then, have the structure, optimized for those given loads.
Yes. 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 Thank you so much, Kevin, for sketching those beautiful cartoons and your insights on paper. Hopefully, it becomes a reality in the near future. Kevin, as a takeaway for all our listeners of this show, could you share a rule of thumb that you have developed or followed during your career that might help our fellow engineers in the community to keep in mind while designing or analyzing structures?
Absolutely. So when you're proposing structural fire design, the natural question that comes along is who's going to pay for this? Um,
Yes.
and I mentioned a project for the LaGuardia Airport where it's really motivated by a safety concern, where in that case, just the merits of the process itself to properly analyze the structural performance get you to be able to do it. But a lot of times, they'll have to be made, some type of economic argument of
Yes.
employing the project to your client. So couple rules of thumb that I use
Okay.
is first, what is the percentage of costs that goes to fireproofing for if you consider the entire cost of a protected steel frame?
Okay.
Now, if you think about conventional structural engineering design, structural engineers will spend a lot of time optimizing the steel tonnage and erection costs under the ambient design loads. But what may be of surprise to structural engineers that don't deal with structural fire protection is although those costs are very formidable, um, fireproofing can account for 20% of the entire protected frame. And it can actually exceed the cost of the structural core of the building.
Yes.
So basically, in my opinion, coming up with an optimized structural design that considers everything except fireproofing, and then handing that off to be blanketed with fireproofing sort of indiscriminately may not be true optimization, and there may be
Yes.
opportunities to synergize the steel tonnage optimization with the fire protection optimization. And the second rule of thumb is if we zoom out even further and we consider the entire cost of the core and shell of the building. Now, in this case, and this may be humbling to structural engineers, the cost of the protected frame is only about 12% of that entire building cost. And even a smaller portion of that is the fireproofing, which is only about 2%. However, that fireproofing, um, which again is only 2%, can, in a lot of cases, be on the critical path for about 60% of the building construction. And that
Yes.
60% is the cost that's associated with the shell of the building, the enclosure, and the services that get installed. And a lot of times, those installations can't be commenced until the fireproofing is, staged, sprayed, cured,
Yes.
and perhaps inspected. And I've been on projects where just the inspection of the fireproofing holds up the construction. Um,
Okay.
so, if you read the Charles Pankow project, the design guide,
Okay.
you can see that there's in a lot of cases opportunities to have about half of the structural members completely unprotected. And also another concept that we convey in this design guide is that the applied fire protection can be engineered as opposed to prescribed. And in that case, you're able to fine tune the applied fire protection to a level that upholds your structural system limit state. So, for instance, in
Yes.
the design that we worked on, we only need to provide enough applied fire protection to the primary members so that their deflection would be controlled to a point where we don't introduce an unstable slab yield line into the membrane. So
Yes. Yes.
we were able to come up with a performance based solution that would allow for a thinner coating to be applied that could be done off-site and would not be damaged that much under transport because the thickness of, say, an intumescent coating, as that gets thicker and thicker under higher and higher hourly ratings, the susceptibility of damage of those coatings during transport on a truck bed increases almost exponentially. So if you're
Yes.
able to fine tune your structural design with an offsite scheme, you could come up with something that alleviates that construction pinch point of the fireproofing causing those delays.
Yes,
And
yes.
we demonstrated in our project this has the potential to save about 1 to 2 weeks of construction per floor. Um, so, given how speculative the building is, this could have a pretty major impact. So this sort of I'm always of the thinking that it's better to forge ahead with a better
Yes.
idea as opposed to
Yes.
spending all our time bashing the existing. But forging ahead with this idea may make people realize that the lack of synergy between structural engineering design and structural fire protection can result in buildings actually being less resilient to fire and costing more than they need to.
Yes,
Um,
yes.
so, I'm really an advocate of a rational allocation of both intellectual resources, which structural
Yes.
engineers are a focus of, as well as physical resources to make our buildings better.
Yes, yes, yes. Those are great two thumb rules that you mentioned for cost effectiveness and efficiency during employing structural fire protection. Kevin, thank you so much for taking out your valuable time for the show today and sharing your advocacy for structural fire engineering. I'm sure this conversation will intrigue many of our fellow engineers in the community to learn more about structural fire engineering. I hope you enjoyed being a part of the show as well. Would you like to share any of your final thoughts today on the show?
Yeah, absolutely. I really appreciate being part of your platform and the dialogue with your audience on this.
Sure, sure.
A message to your audience would be, come join the structural fire design movement if you have an interest. The water's warm.
Yeah.
Um, and one good place to start if you haven't been exposed to it is that ASE design guide that we came out,
Yes, yes,
because it really brings it all to life. It's not sort of theoretical, and
yes.
it's free too. So we're hoping that
Yeah, yeah.
that guide can be a way for people to legitimize their advocacy for it.
Yes,
And
yes.
it's really a new frontier, and it's an exciting area to be part of, because there's um, so much ripe to be innovated and optimized that, if you were to go into this realm as a structural engineer, I think you could really make your mark, because there's so few people looking at it right now.
Yes,
Um,
yes.
and, I think that as a structural engineering community, we really should be looking at structural fire design with a heightened sense of urgency because, our buildings are rapidly evolving and the change of structural systems, may be outpacing, what was originally envisioned 100 years ago, for
Yes,
structural
yes.
fire protection technology. So if we continue to mate, century-old technology with an evolving technological, advancements in structures,
Yes.
we really need that better synergy. And eh, another thing is structural fire protection is, the union of both structure and applied fire protection. So, as we go forward and develop regulations, it's really important that we have a balanced representation from, all of the materials that are involved, including the structural
Yes.
materials and the applied fire protection materials and engineers as well. And, I'm really confident that we're going to do that and we're going to continue
Yeah.
to make things better. And, again,
Yes.
thank you very much and, stay safe during these times.
You too, you too. It was a pleasure hosting you. Thank you so much everyone for watching this video. Make sure you like, share and comment your thoughts and questions on this video. Type in any questions that you would like to ask Kevin as well in the comments below, and make sure to subscribe to this channel to help us grow our structural engineering community. See you all in the next episode soon.